As you can see, the ball doesn't have any texture. And what I actually want to do is be able to rotate the ball, so I'm able to actually give it an impulse so it can go forward and that I can actually see where it is. So first, what I would like to do is actually add some texture to this Roboball. Let's see how to do that, which means I have to go to mesh of the Roboball. The mesh was part of the model asset of a component, and then this was kind of like the model asset. I believe that I would need to go and find... I actually have to add a material component. I think that's what I'm supposed to do. So material component. Okay, so I can generate manage source materials, and if you see, like, we should probably rename this because this is one of the standards. So I think it would be better maybe select something else. Oh wait, okay, so like generate source materials, then I open up the material editor, which is Roboball texture material. Oh, I guess I've already made this before, so yay. Okay, so perhaps best to kind of show you like where you can actually add texture itself. That is like part of the base color right here. And then I selected one of the default NelfS.tifs that you can add from the O3DE editor itself. So that is default NelfS.tif in O3DE assets, engine, defaults, and default NelfS. So it's just a couple of squares. And yeah, so that is what I used. And you can also give it a different color if you like, red or so. But I'm just going to keep it gray, very grayish for now. So, but yeah, let's see. But at least like it already has some texture. Interestingly, that it wouldn't give that error. So I make sure to feedback that back to the O3DE peeps. Does it have that material? I would need to actually add the material that I just made to the actual material component. So, and that is actually in my own asset folder in materials and Roboball texture. Oh yeah, there you go. There you go, finally something. So yeah, but I'm now kind of like rotating the arrow messages, and it's not really responding right now. Like I don't see it even rotate. It doesn't even really look like a ball. So yeah, let's see if we can definitely improve that in the Lua script. At least like we would like to then now make a rotation. So instead of let's say there's another function called apply angular impulse, which you can also create a vector, but instead of like x, y, and z, that is roll, pitch, and yaw. So that is going to be something potentially that I can use here. So let's change this to apply angular impulse, self entity ID vector. Yeah, but now this is of course not a trans-linear impulse, so I have to then potentially do then something else and maybe do the impulse direction from there. I don't know how much that's going to be. Control save and then play the game again. And then, okay, so it's rotating very, very slowly. But it's actually not really going into the direction that I wanted. So it's only rotating, but it's still applying a forward impulse. So that is a little bit... yeah, that is not exactly what I want. We would like to kind of see where the Roboball is looking at, and then apply the linear impulse in world coordinates, because that's in world coordinates, towards like the heading of the ball. So we would need to actually achieve that by getting the rotation of the ball. And we need to do it quite often because we're constantly giving an impulse direction on each tick. We're going to add the following function to kind of the transform bus to retrieve the actual rotation. So local rods is then transform bus and event get oriented world rotation, and then is then self entity ID, which is the ID of the Roboball. And then let's debug it just to make sure that are actually receiving it properly. So it's going to be in radians and you're going to see it in the console. So 0, obviously. Okay, so it's definitely rotating them. So okay, so these are the values in radians. So it's then you see kind of like the current heading of what I want to actually show. So that is nice. Yeah, let's work with that heading. Back to the Lua script. We have the rotation, potentially also want to do something with the impulse size, potentially. Yeah, maybe we have to put the impulse size then over here. So like local impulse size self.properties, size, very nice. Okay, and that's the one that we're actually getting from, that's just from the properties itself. And then we are going to do a new 2 values, so like one local x new and pulse size times, and then you rotate from, we will rotate it with like a cosinus with the actual heading, which is already in radians, because you get you want to apply the impulse size not on the world coordinates but on the body fixed coordinates. So then it's going to be math cosinus rotation the yaw, and then local y new impulse size math. It's not math, but math. I'll fix that later. Rot. So yeah. Okay, and so this is then going to be then what you actually apply on the linear impulse. So let's copy paste that, put that down, then let's put the new coordinates for the impulse that is applied on the Roboball, put then in like the impulse size actually based on its heading. This transform is done usually like, you know, you got it from a transformation matrix, but because it's just in the 2D plane and y is 0 in world, it's just these 2 lines, so it's quite easy to implement. Let's do that. Let's see if it actually reacts on, actually applies the impulse, the linear impulse on the actual heading of the Roboball. Let's do it. Okay, so let's rotate. Let's definitely make it a little bit faster because it doesn't rotate so fast. Yeah, okay, so see, it's now following its heading. That's pretty cool. So we now have a ball and it can rotate and it will follow that rotation. Yay! And I can actually also see where it's going, kind of, because it now has texture. So pretty cool, but now it's kind of using a rotational impulse, which is kind of like also playing with the forces, but I want to improve that control a little bit. Like, how about me just rotating it? Ah, too late. See, then like now I have less control over it because it's like I'm playing with the impulses, but it would be nice if the rotation will be actually kind of a fixed rotation. So let's change it from a rotational impulse to a rotation, a speed or an angular velocity, for instance. Here is the Lua script again. Let's add another property to it, which is going to be called angular velocity is 0.2. Yes, compilation is successful. And then in the onPressed, which is the response that it will get if I press on one of the arrow keys, which I've assigned in the previous stream by key bindings, let's put a self rotation direction to a certain value, which is the value, which is 1 or -1. That's kind of like dependent on if I press the right key or the other one. So I'm going to comment this part out, and then on tick, which is run every frame of the simulator / game, I would like to add a set angular depth first. Yes, let's do that after we've applied the linear impulse. Local fill self.rotational direction, which is now a global variable, times self.properties angular velocity. So I can still change that wanted angular velocity. So request bus, rigid body request bus, but event, but set angular velocity. Ah, I now have autocomplete. Self.entity ID vector 3. And then, because it's again looking at the rotation, both pitch and yaw, pitch and roll is 0, but around the z-axis, which is this way, is yaw. Still building, right? So there is now a angular velocity, but when I stop pressing it, it will still continue, which is not exactly what I want, maybe. So I would need to nil or make the rotational direction at least, or I mean this value 0 again. So that means it's then self direction is going to be 0, and therefore like this is going to be 0 as well, so it won't go in that direction. Play it again. So then I only play it once. Now it hardly responds, and I don't want to press all the time. So if you use the function onPressed, that is only when you press it once, but if you press it on held, it will be activated every time. Like for every tick that the button is actually held or event or something like that. So I'm going to change this to held as well. And then if I this one, then yeah, it will still, and it will stop if I actually release the button. So that is what, at least what I want for now. But let's make this rotational velocity a little bit higher. 5.5 rod. So yeah, I've made some changes now, so that this is now OnHeld, the rotation direction on 0, and it's also now actually changing the angular velocity and then applying the impulse to the forward impulse to the Roboball based on its heading. That's already what I've implemented before. Yeah, so that is kind of like what the total code is supposed to look like. What I do want to improve a little bit better now, because now the ball is actually rotating, is that to maybe improve the camera rig a bit. I want it to rotate with the ball so I can actually see where it's going. Yeah, that is something that we can implement as well. Let's first save this. Everything's still working. Perfect. Make sure before I move on to fix other things that I don't break anything in the meantime as well. It sounds reasonable. Sounds very reasonable. Okay, let's improve the camera rig. As you already noticed, game follows the ball, but when you rotate it, it won't follow it with it. So like third person view game. So we can actually change the camera rig a bit. So like this is the entity that actually does the camera. And we've already added a rig last time, but we had some transform behaviors that only follows the ball from one direction. So that is maybe not per se, like, you know, the actual behavior that we want. Let's improve it a bit. We're first going to add a new transform to the camera. So I want to already place it in a place that is a little bit more logic. So that's going to be, if we want to be the editor camera, or the game camera is -5, 0. The rotation here in this game is a little bit like, I know, you still get confused a lot of times where the right coordinate system is here. So like for anything, it's always good to double check which way is the which way. Okay, so it's already on the right location. Let's select the camera entity, remove the transform that we had, which was the follow with rotate or something like that. We are going to follow target from angle. We're going to remove that, and we're going to add a follow target from distance to be 10. The follow distance can be 5, and the minimum distance can be 1. Not necessarily sure if any of this is being used at the moment. I think you can also apply that to the event, so in certain parts it will actually go towards the ball, but now it will just follow. Let's see if we can already see a difference. Okay, yeah, but it's a little bit too close. Or wait, where? Oh, okay. Yeah, it's actually not facing the ball. So let's make it face the ball, the camera. So let's go back to the camera rig component. And then we want to add one more transform element. Face target. Target is current. So it's a bit on the side, like I said. The axis is a little bit weird on this one. I'm going to cheat a bit. So I'm going to make a child entity on this one. And I'm going to call it camera target. I'm going to rotate it. And then I'm going to add the camera again. The camera rig, and I'm going to replace this entity with the camera target, which is a little bit too low. Let's improve it by adding it back up again. That's a little bit too high. There you go. Alright, and the final improvement is that I would like it to be a little bit more higher. So not really actually looking directly at the ball. I want it to look a little bit above the ball, or technically the camera target. Yes. So that means the look at behavior of the camera rig is going to be the offset position. When we add that, and then we can add, like, you know, 1 meter up, so it will look 1 meter up. Yeah, okay, I think that's a way more natural way to actually look at the ball. And then I can control it, and it will follow also as well. So like I said, I didn't even show that before.